Okay, we're taking a look at 2016 free response number 5. Okay. All right, so on number 5 here, we have a funnel of height 10 inches, which has circular cross sections as shown in the figure above. So that means that if I were to cut this in like a loaf of bread, there would be circular cross sections at each of my slices. Okay. At height h, the radius of the funnel is given by r equals 1/20 times 3 plus h squared, where h is between 0 and 10. The units of r and h are in inches. For part A, find the average value of the radius of the funnel. So, do you remember how to find an average value? Average value is integral over interval, or another way that we wrote it was 1 over the interval times the integral. Okay. In part A, for this interval, we're talking about the radius function, which is terms of h, and h is measured between 0 and 10. So I would do 1 over 10 minus 0 times the integral from 0 to 10 of the radius function, which is 1/20 times 3 plus h squared dh. Okay, so 1 over 10 minus 0, that's just going to be 1/10. The integral from 0 to 10 of 1 over 20 times 3 plus h squared. Okay, so what we're going to do is we're going to take this 1/20 and we'll move it on the outside, just so this integral is easy to work with. 1 over 200 integral 0 to 10, 3 plus h squared. Okay, so to evaluate an integral, what we'll need to do is find the antiderivative. To find an antiderivative, you would add on a variable whenever you just have a plain old number. And then for h squared, you add 1 to the power and divide by the new power, and then we'll evaluate this from 0 to 10. The 1 over 200 is still out in front. Okay, we're going to plug in 10. 3 times 10 plus 1/3 times 10 cubed minus 0, because when I plug in 0, I'm going to get 0, so that doesn't change anything. And then I have the 1 over 200 still out in front. 3 times 10 is 30, plus 10 cubed is 1,000 over 3. I'm going to add these two numbers on the inside. In order to add those, they need a common denominator. So 90 over 3 plus 1,000 over 3. Okay, so this would be 1090 over 3 times 1 over 200. When I multiply these two fractions, we just multiply straight across. So 1090 over 600. Okay, and we're going to try and reduce it. I know you don't have to reduce it when it comes to the exam itself, but a good practice would be to reduce the fraction if we can. Okay, so let's go ahead and try and reduce this. This one's pretty easy. We could divide both the top and bottom by 10. So the 10s would cancel, or the zeros at the end would cancel out. So I'd have 109 over 60, and nothing goes into those. 3 doesn't go into both. 2 doesn't go into both. 5 doesn't go into both. Those are just some kind of quick checks, but this isn't reducible any further. So my final answer would be 109 over 60 inches. 109 over 60 inches. Okay. All right, part B. To find the volume of the funnel. Okay, so this problem, it says the inside of a funnel, it has circular cross sections. Now, for cross sections, we need to think about adding up all these cross sections to get the volume. Okay, so it's kind of like taking that loaf of bread and then adding up all the slices to get that full loaf. Okay, so if we look at the volume of just one slice, one circular cross section, and then add them up, going all the way up and all the way down, then I can find my volume. Okay. Now, so what we'll do is we'll look at the area of just one cross section, and it says that there's circular cross sections. So area of one circular cross section, the area of a circle is pi times the radius squared. Okay. So the pi would stay. My radius is given by that function, 1/20 times 3 plus h squared. I'm going to square all of that. Okay. Okay, so we are going to take the integral from 0 to 10, because that's where all my radius, or that's where all my circular cross sections are, from 0 to 10. Okay. Pi times 1 over 20, 3 plus h squared, squared dh. Okay, so we're going to go through the process of cleaning this up and then solving it. So I can move the pi out in front. That'd be the easiest thing to do. And then I'm going to start squaring some things on the inside. When I square 1 over 20, I would get 1 over 400. And then I'm left with 3 plus h squared squared. So let's leave that for just a second, right? And then what I can do is I can move that 400 out in front. So pi over 400, integral 0 to 10. Then let's go ahead and square 3 plus h squared. So when I square that, remember that's 3 plus h squared times 3 plus h squared. Okay? Whoops, that's where it should be on the inside. So I'd have 9 plus 3h squared plus 3h squared plus h to the 4th. Okay? So pi over 400, integral 0 to 10, 9 plus 6h squared plus h to the 4th dh. And now it's just a matter of simplifying this integral. We'll add on a variable, plus add 1 to the power, divide by the new power, plus add 1 to the power, divide by the new power. And then we'll evaluate it from 0 to 10. Okay, the pi over 400 stays out front and just kind of goes for the ride. Okay. Let's plug in the 10. So 9 times 10 plus 6 over 3 would be 2 times 10 cubed plus 1/5 times 10 to the 5th. And when I plug in 0, I'm just going to get 0. There's no numbers that would throw this off at all, right? Because they're all variables here. When I plug in 0, I would get 0. Pi over 400. Okay? Okay, let's keep going to simplify this. Pi over 400 times 90 plus 10 cubed would be 1,000 times 2 would be 2,000. Oops, one extra 0 there. Plus 5, and then 10 to the 5th would be 100,000. No, 10,000. 10,000. Whoops. Okay. Let's keep going, seeing if we can simplify this. I know we don't necessarily have to, but again, it's just kind of good practice. So pi over 400. Well, we do need to simplify this as much as we can. So what I would do is I would change those all to be over 5. So let's see here. 90 times 5 over 1 would be 5, or 5 over 5. We're going to multiply each of these by 5 over 5. So 45, 9 times 5 is 45, tack on a 0, you have it over 5, plus 5 times 2 is 10, keep the 3 zeros there, over 5 plus, and then the 10,000. Nope, I am missing a 0, aren't I? Yeah. Over 5, yep. Okay. Let's keep going, pi over 400. So I have 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, and then 450, 0, 5, 4, 0, 1, 1. Okay. Okay, multiplying straight across 110,450 pi over 2,000. 20 and then 2 zeros, yep. Okay. We can try and reduce this. If you do reduce it all the way, I won't go through that whole process, but I mean, you can take off the zeros here, divide them by 5, kind of keep going from there. Okay, 11,045 pi over 200. Okay, we can keep going and divide both the top and bottom by 5, and you should get 2209 pi over 40 inches cubed. Okay, that would be my volume. Okay. Again, if you just got this number, that would be fine. You did the work, you got the right answer, you just didn't reduce the fraction all the way, so that would be fine. You would still get all your points for this answer. Okay. Part C. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay, so whenever I see a rate of change with respect to time, one thing we can be thinking about is a related rates. Okay, so we're going to need to kind of connect some of these different rates that are given to us to create this chain rule, to create this related rates type equation. Okay. Okay. So I don't have a function, a specific function for dH, right? The rate of change of the height. So instead, what we can look at is dr dt. We can look at dr dt. Okay, dr dt is the derivative of the radius function. Okay, so let's write that first so I can see it. Radius is 1/20 times 3 plus h squared. Okay, and then what we're going to do is let's take a derivative and see what we get. Dr dt equals, this is equivalent to 3 over 20 plus h squared over 20. Okay, it might help you. You could keep it as 1/20 times h squared, just so you can kind of see that 1/20 is a number out in front. Now we're taking the derivative of this with respect to time. Okay, so the derivative of 3 over 20 would be 0. That doesn't impact anything. The derivative of 1/20 h squared, right? The derivative of this, the 1/20 would stay. The derivative of h squared would be 2h. And then the derivative of h with respect to time would be dh over dt. Okay, so what I'm going to need to do is I'm going to need to solve for this, right? Because it wants to know what is the rate of change of the height with respect to time. That is a dh dt. Okay, so let's plug in what we know. Maybe we have enough information here. If we don't, then we'll try and solve for what we need. Let's see, it says at the instant when the height of the liquid is h equals 3. So let's plug in 3 for h. 1 over 22 times 3. And then it says the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. So because it's a decreasing rate, it would be negative. So that is the rate of change of my radius. This time it's negative. Okay. So all we need to do is just solve this for dH dt. The 2's would cancel, right? And I'd be left with 10 in the denominator. Okay. So that would be 3/10. And then what I'll do is I'll multiply both sides by 10/3. That way these fractions cancel out and I'm left with dH over dt. And then the 1 and the 5 and the 10 would reduce to negative 2/3. Okay, and dH, h is measured in inches, t is measured in seconds. So the height is decreasing at a rate of 2/3 inches per second. Okay, let's talk about the points on this one. As far as points are concerned, for part A, you would get 1 point for your integral, kind of setting it up, 1 point for your antiderivative, and then 1 point for your final answer. Okay. For part B, you would get 1 point for setting up the integral, 1 point for an antiderivative, and then 1 point for your final answer. Now remember, any 3 of these would be equivalent and would still get you your point. So to save time, if you feel like you're running out of time, don't reduce the fraction and you can just leave it. Okay? I know it's not the best thing to hear. I mean, I know if I was grading this, I'd want to see the fraction reduced for my classwork, but for the AP exam, you don't have to reduce the fraction. For part C, you would get 2 points for the chain rule, so 2 points for this line, kind of an all or nothing type deal, and then 1 point for your answer. Okay? All right, let me know if you have any questions.